At first, happy New Year 2024 to all of our viewers. Scientists reveal how the element's electrons chemically bond when under pressures like those found below, travel deep enough below the Earth's surface or inside the center of the Sun, and matter changes on an atomic level. The mounting pressure within stars and planets can cause metals to become non-conducting insulators. Sodium has been shown to from a shiny gray colored metal into a transparent glass-like insulator when squeezed hard enough. While it's been theorized that high pressure essentially squeezes sodium's electrons out into the spaces between atoms, yeah, researchers, quantum chemical calculations show that these electrons still very much belong to the surrounding atoms and are chemically bonded to each other. They told, we are answering a very simple question of why sodium becomes an insulator. Predicting how other elements and chemical compounds behave at very high pressures will potentially give insight into bigger picture questions. Eva Zurek, PhD professor of chemistry in the UB College of Arts and Science and co-author of the study, which was published in Angewandte Chemie, a journal of the German Chemical Society. What's the interior of a starlight? How are planets' magnetic fields generated? Indeed, any exist? And how do stars and planets evolve? This type of research moves us closer to answering these questions, Zurek continued. The study confirms and builds upon the theoretical prediction of the late renowned physicist Neil Ashcroft, whose memory the study is dedicated to. It was once thought that materials always became metallic under high pressure, like this metallic hydrogen theorized to make up Jupiter's core. But Ashcroft and Jeffrey Newton's seminal paper 2 decades ago found some materials like sodium can actually become insulators or semiconductors when squeezed. They theorized that sodium's core electrons, thought to be inert, would interact with each other and outer valence electrons when under extreme pressure. Our work now goes beyond the physics picture painted by Ashcroft and Newton, connecting it with chemical concepts of bonding, says the UV-led studies lead author Stefano Reciupi, PhD postdoctoral researchers in the UV Department of Chemistry. Pressures found below Earth's crust can be difficult to replicate in a lab. So using supercomputers in UV Center for Computational Research, the team ran calculation on how electrons behave in sodium atoms when under high pressure. The electrons became trapped within the interspatial regions between atoms known as an electrite state. This causes sodium physical transformation from shiny metal to transparent insulator as free-flowing electrons absorb and retransmit light, but trapped electrons simply allow the light to pass through. However, researchers' calculations showed for the first time that the emergence of the electrite state can be explained through chemical bonding. The high pressure causes electrons to occupy new orbitals within their respective atoms. These orbitals then overlap with each other to form chemical bond, causing localized charge concentration in the interstitial region.